Welcome back to Aurora Tech channel. Today I'm super excited because I'm going to unbox, assemble, and review this COREXY 2-tree Sapphire printer. Okay, let's unbox it and see what's inside. It looks like there are a lot of parts. This will probably take more time to assemble compared to my other Cartesian printers and the box frame Ender 5 Pro. I have already assembled and then disassembled this printer before recording this video. There are several points you need to address during assembly. Before we start, we actually need to prepare some things that didn't come with the printer. 1. Some breadboard cables to extend the 3D touch. The cable that came with it is way too short, so I need to extend it another 80 centimeters in order to reach the connectors on the motherboard. 2. You also need two M3 by 6 mm screws to fix the 3D touch on the print head mount. It came with the screws to fix the 3D touch to the mount, but it didn't come with the screws to fix the mount to the print head mount. You also need a tiny Phillips screwdriver to fix the Y-limit switch, but it also didn't come in the tool bag. Finally, you need to adjust the cable on the hot end, or it may move too close to the heat block and melt the cables. As you can see, the heatsink cooling fan cable actually touches the heat block when it prints, so I have to adjust the cable to make sure there is enough clearance between the heat block and the cable. Putting a silicone sock on the heat block is also recommended. This will be the last item you need before you start. For now, I will assemble it again in front of the camera to make sure the process is smooth and that the information you get from this video is correct. Let's put all of this together. I will try to make the assembly process simple and easy to follow. First things first, we always want to check the voltage of the power supply. This printer is slightly tricky because the switch is hidden inside the base and is located right in the power supply unit. Make sure it's set to 115 volts if you are in the US. Now we can start our first step. In this step, we will connect the base with these 4 aluminum extrusions. Grab the screw bag that is labeled as A2. Take out the 2 small bags inside, the M5 by 16 mm which are silver, and the M5 by 10 mm which are black. These are the only screws we need in this step. There is some tape to secure the cables, but don't remove them yet. We want the cables to stay here for now. Flip the base and we will do the first corner. Let's start with the corner with the power switch. Please be aware that these 4 extrusions are not identical. You have to place each of them in the correct corner and make sure they're facing the correct direction. There are 2 checkpoints you need to confirm before you tighten the screws. First, the V slot of the extrusion should be facing inside, and the drilled hole should be facing up. Take a look at the picture. This is incorrect as the screw hole is facing down. Tighten the screws at the bottom first. Use the black M5 by 10 mm screws, but don't tighten it all the way yet. Then, tighten the screws from the side using the M5 by 16 mm silver screws. We can now adjust these 4 screws to make sure the extrusion is aligned correctly. Tighten the side screws a bit and the bottom screws completely. Finally, tighten the side screws all the way. This is very important. since this printer uses linear rails to move up and down, unlike the rubber pulley wheels which can be self-adjusted even if you didn't align them perfectly. Do the exact same to the other 3 corners. Make sure the slot is facing the inside and the hole is facing up. Carefully tighten the screws to align the frame. When you're done, the frame will look like this. Step 2. Z-axis linear rails. In this step, we will add the Z-axis linear rails to the frame. Grab the linear rails, which have been attached to the 20 by 40 extrusions. We need these two 20 by 20 extrusions, the same screws from the A2 bag, some M5 by 30 mm screws from this small bag over here, and we need the M5 by 10 mm black screws from the same A2 bag. We also need the grease from the tool bag. Apply some grease to the rails first. If you do this after the assembly is completed, it may be more difficult to apply it evenly. These linear rails are identical, but the longer black empty space should go to the base. Use 2 black M5 by 10 mm screws to secure them to the base. After you finish, your frame will look like this. Then, we can put these 2 short 20 by 20 extrusions on top of the linear rails. They aren't identical, but it's not hard to tell which is left and which is right, as you can't align them if they are at the wrong side. The side with bigger holes should face up. Use these long black M5 by 30 mm screws, 2 for each side to secure them. Right now they can still move, so we will install 4 angle brackets to secure them to the frame later on. Step 3. The COREXY belt. In this step, we only need the belt, which is inside the A4 bag. You actually need to cut it in half since we need 2 belts, one for the X stepper and one for the Y. The manual actually suggests for you to install the hot end first, but I will do the belt first. As you can see, there are some wheels on the frame. Some of them have gears and some are flat. All upper wheels are for the X motor and the lower wheels are for the Y motor. I will start with the belt for the X stepper motor. In this process, we will use all upper wheels at all points. First, go through this gap on the hot end mount. Make sure the teeth lock onto each other and use a zip tie to secure it. Now, the flat side of the belt is facing the stepper motor. This flat wheel without gears is the first stop. We need to go around this wheel and then go around the stepper motor. The teeth on the belt will match the gears on the motor. Next, go the long way to the opposite corner. Go around the wheel with gears, and the teeth on the belt will match the gear as well. Go another long way to the other side, and also go around the top wheel with the gears. Then, go back to the wheel on the linear rail. The teeth will match the gears on the wheel. Finally, we're back at the hot end mount. Go through the gap and let the belt lock itself with the teeth. Now, secure it with a zip tie. We don't want a loose belt or an overly tight belt. You don't have to cut anything yet, since we may need some final adjustments when we do some test prints. The Y is the same as the X, but this time we will use the lower wheels. Start with the other side of the front. Go around this flat wheel, then the Y stepper, and go the long way to this corner. Go another long way to this corner, and we have now reached the final wheel mounted on the linear rail. Secure it on the back of the hot end mount. If you did everything correctly, you can pull the belt and the hot end mount is moving at a 45-degree angle. Step 4. The top. In this step, we will attach the top to the printer. We need the top and the same screws from the A2 bag. Just like how we connected the base, we also need 8 M5 by 16mm silver screws and 8 M5 by 10mm black screws. We also need to apply some grease to the rails first. We can now attach it to the frame. As you can see, the X and Y stepper motors are on the same side. This is the front. This front side should face the same direction as the screen. Put the black screws on top, but don't tighten them all the way yet. Put the silver screws on the side, tighten them a bit, tighten the top screws all the way, and finally tighten the side screws. Do the same to all 4 corners. Step 5. The angle brackets. In this step, we need to grab the angle brackets bag labeled B1. We only need this bag in this step. Put the screws inside and attach the T-nuts to the screws. The round side should be facing the outside. Turn them 1 full circle to make sure they won't drop, and we will tighten them once we set them in their positions. We need 2 on each Z-axis. Do the same to all 4. After you're done, the Z-axis should be securely attached to the frame. Step 6. The heated bed mount. In this step, we will attach the heated bed mount to the linear rails. Grab these 2 mounts. We need 8 unlabeled black screws from the B3 screw bag. These heated bed mounts need to be installed in the correct direction, or the bed will be too low. The flat side should face up. Put 4 screws on each side, but don't tighten it too much, since we may also need to align them later when we turn on the printer. Step 7. The Z-axis lead screws. In this step, we just need to add these 2 lead screws. Go through the heated bed mount and down to the blue couplers. This part is quite straightforward. Just screw it all the way down and secure the screws. If you did that correctly, you should be able to smoothly move both sides up and down by turning the blue couplers. Step 8. The Z end stops. The Z end stops are mounted on top of the lead screws. As we have a 3D touch leveling sensor, we actually don't need these end stops. I wouldn't connect the cables to these end stops, just use it as a mount to secure the lead screw. In my case, one of the lead screws that came with the printer isn't straight, so it works better without this mount. But for now, I will just put them on. Step 9. The heated bed. In this step, we need to group these items together: the heated bed, the sticker print surface, and the temperature isolation foam. The screws we need are in bag B7. Don't put the print bed together yet. If you stick the blueprint surface on now, you can't install the bed. I've decided not to use this sticker, not because it doesn't work, but if anyone has experienced having to replace the sticker print surface of an Ender 3, you should have already switched to a glass bed, a magnetic bed, or a PEI spring steel sheet. First, remove the protector film. Then, stick the temperature isolation foam at the back and apply some pressure with the roll to make it flat. We can put these 4 long screws in the screw holes. Put the blue springs between the bed and the mount. You can use some tape to help you secure the springs when you align the bed with the mount. finally, screw in these tension adjustment knobs. Don't tighten it all the way since we still need to adjust it later when we turn on the printer. Step 10. The extruder. This part is quite straightforward. In this step, we need to grab the C2 bag. We have an extruder which is mounted on a stepper motor. There are some loose parts, including a long screw, a spring, and a washer. This is a tension spring for us to adjust the grip on the filament. We can put them in order like this, so we can turn the screw to adjust how tight we want the extruder to grip the filament. Then, we will use the T-nuts and screws to mount this extruder to the left side of our printer. Step 11. The filament holder and filament runout sensor. This part is also pretty straightforward. All you have to do is mount the filament holder onto the frame and you're done. For the filament runout sensor, it didn't come with a mount. So if you want to use it, it's going to flow between the filament roll and the extruder, which should still work. But for now, I'll just leave it until I design a mount and fix it to the frame. Step 12. The hot end and the X-limit switch. As you can see, there are 3 screws already mounted at the back of the support plate. To mount the hot end, you can just unscrew them and use them to mount the hot end. After that, fix the Y-limit switch here. We will use the 2 M2 by 10 mm screws from the B3 screw back to fix it. Step 13. The 3D Touch. Inside the 3D Touch bag, you can see there are 2 M3 screws and nuts. I will put the nuts between the sensor and the mount. If you don't do that, when you use the sensor for auto home or bed leveling, the nozzle will crash into the bed before the pin can sense it. It will reverse it to let the wire face the front so that it's easier for wiring. Step 14. Connecting cables. In this step, we will connect the cables, which are for the X stepper motor, the Y stepper motor, the heated bed, the Y-limit switch, the extruder, and the 3D Touch sensor. Assuming you already have an extension cable ready, you can connect the pins to the motherboard. By default, there are 2 cables for the Z-limit switches. As I won't use it anymore, I will just remove them. Then, connect the black and white wire to replace the Z-limit switch on top, which is the Z-min switch. You can see there is a 3-pin BL Touch connector on the motherboard. The red is 5 volts, the yellow is signal, and the green is ground. Make a final check on the connections and make sure that they look like this. Step 15. Connecting the PTFE tube. This step is a simple process, but you still have to be careful. The PTFE tube should go all the way down to the hot end and touch the nozzle, or it will be clogged badly. But how do we know that it's touching the nozzle? The best way is to take off the nozzle and see the end of the PTFE tube. Since the inside of the hot end may not be that smooth and allows the tube to go all the way to the bottom easily, it may give you a false signal. When the tube is inserted halfway, you feel that it can't go any deeper since it was stopped by something. I actually did push it all the way and it clogged the nozzle. I have to take everything apart and fix it. The thermistor is also difficult to or even impossible to remove. This makes the process even harder. I had to break it. I needed to replace the thermistor and the heat block. So please make sure you did it right in the first place to avoid all this trouble. The hardware assembly is done. Before we can turn on the printer, we still need to do several things. 1. Remove the rubber stops from the linear rail so it won't limit the range for the Z-axis. 2. As the firmware of this printer didn't enable 3D touch bed leveling, we also want to update the firmware to enable the 3D touch before we turn it on. You can follow the instructions that came with the printer to update the config file, but the instructions aren't too clear. I found out that you actually need to modify much more than that to make the leveling system work. I made a few adjustments to make it work better. If you want, you can follow what I did. Change Z2 end stops to 0, as we are no longer using both Z-limit switches. Change Z2 use end stop to 0. Change X max pause to 305 and Y max pause to 305, as the default was 310. I want to leave some margin so it won't print right at the edge or outside the bed if there's any misalignment. Change filament change Y pause to 295. I want the nozzle to park at the top left corner when I change the filament. Change default X max acceleration and default Y max acceleration to 3000. This printer can print much faster, so instead of 1000, I want to max the acceleration to 3000. Change min software end stops and max software end stops to 0. As we need to adjust the Z offset below 0, I will disable the software end stops. Change Z min probe pin mode to 1, since we're connecting the 3D touch black and white cable to the Z min end stop connector. For the Y probe offset from Extruder, set it to -45 as it's 45 mm in front of the nozzle. Set Z safe homing to 1, as we want to do auto home in the center of the bed. Set bed leveling method to 3, since we are going to use bilinear bed leveling and probe the bed with 25 points using a 5x5 grid. Set grid max points X and grid max points Y to 5. That allows us to probe 25 points. Set left probe bed position to 40, right to 260, front to 40, and then back to 260. This will define the margin that the probe can reach. Finally, set BL touch to 1 to enable the auto leveling sensor. Then save the file. You need to copy 4 items to your micro SD card to flash the firmware. Copy 2 folders, copy 2 files. Copy them to the root of the micro SD card and turn on the printer. After a while, your printer is ready to use. Now the printer is ready. Do auto home. And after that, move the Z-axis and use the paper test to find out the distance between the sensor pin and the nozzle. In my case, the perfect number is around -1.95. We can save this Z offset value to the printer. Go to Settings, Machine Settings, Machine, Next, Leveling Settings, Probe Z-axis offset. Enter the value -1.95. The menu design of this firmware isn't really organized. After you spend some time on it, it's not that difficult to navigate. Then do auto bed leveling. I will now start a test print. I will just print a 1-layer file to make sure the bed leveling is working. But it seems I still need to adjust the baby steps for the first layer. I later found out that this is a firmware issue with the motherboard. It is still able to print, but I will talk about this issue later. Now, I will print a phone stand I designed in Fusion 360. Since this is a simple print, I will try to speed it up and see how fast this printer can print. It looks like I can print at 150 millimeters per second with pretty good quality. Okay, let's talk about some issues that this printer has. There are quite a lot of them, but I would consider them all to be minor issues. 1. A bad manual. The manual is missing a lot of details, so you may have some problems if you follow the manual to build this printer. 2. Missing screws and tools. 2 M3 by 6mm screws and a Phillips screwdriver didn't come with the printer, so if you don't have spare parts and tools at home, you may not have been able to assemble this printer. 3. The hot end wiring safety issue. The fan cables are actually too close to the hot end, so when it prints, some of them will touch the heat block. As you can see, the heatsink cooling fan cables melt after doing a few prints. 4. The 3D Touch cable is way too short. That makes the leveling system unusable unless you can get yourself an extension cable. 5. The thermistor cannot be removed from the heat block. If the hot end got clogged, it would be very difficult to fix it, unless you replace the entire heat block like I did. 6. The stepper drivers. This printer uses 3 TMC2208 silent stepper drivers, plus 2 A4988 noisy stepper drivers, so when it prints, it's pretty quiet. But when you do auto home and bed leveling, it's just as loud as an Ender 3 with a stock 8-bit motherboard. 7. The 3D Touch auto leveling issue. After you set the correct value for the Z offset, when it prints, the first layer is always off. If you just leave it, the nozzle may print in the air 0.5 to 1 millimeter away from the bed, or it will crash into the bed. You need to watch the first layer carefully and adjust the baby steps. When I tried to search this issue online, I found that others also have the same problem. It seems that the problem is caused by the motherboard firmware. This printer is using a maker-based Robin Nano V1.2 board. Not only are Sapphire Plus users having this issue, but other users using the same motherboard have this issue as well. After doing many tests, I found that sometimes the Z stepper motors pause and keep turning when you do auto home or bed leveling. This happens randomly, but when it does happen, the probe result becomes very inconsistent. That's why the nozzle is way too high or too low, even if you set it to the correct Z offset. But after I compiled a copy of Marlin firmware and uploaded it to the printer, the problem was fixed. I will cover this in my next video. I believe some of the other issues are independent cases, since they only apply to the printer I received. 1. Some screws for the blue coupler were also missing, but because I have many spare parts, that wasn't really an issue for me. 2. One of the lead screws isn't perfectly straight. I had to remove the Z-limit switch mount so that it would move smoothly. The metal sheet bottom cover of the base was bent. It requires some extra force to tighten the screws, but it's not that big of a deal. In conclusion, although this printer has a few quality issues, I think that it still has a good value. The best part is that the metal frame is very rigid. If we just bought a metal frame and 4 unbranded linear rails, it would have cost almost $300 including shipping. This whole printer only costs $375. Although the other parts that came with it are relatively cheap in terms of quality, it's still worth the price. I would recommend this printer if you are capable of doing some fixes for some minor issues, and if you have some 3D printer spare parts at home. After the issues have been taken care of, this printer still prints pretty well. But for beginners, if this is your first printer, I would suggest choosing an Ender 3 V2, CR6 SE, Ender 5 Pro, or the Sovol SV01. These printers work so much better out of the box. They don't require too much work to print nicely. If you're interested in those printers, you can check out my other videos. Since this printer has a lot of potential, I'm going to make another video and focus on the firmware upgrade. That's it for this video. If you like this video, please hit the like and subscribe button. My brother and I make a new video every weekend, so check out my channel on Mondays and you'll see something new. See you next week.